Welcome to ClickMyProject.com. The title of the project is Deep Concatenated Residual Network with Bidirectional LSTM for 1 hour ahead wind power forecasting. The abstract of the project is wind ramps introduce significant uncertainty into wind power generation. Reliable system operations, however, requires accurate detection and forecast of wind ramps, especially at high penetration level. A deep residual network for improving time series forecasting models indispensable to reliable and economic power grid operations, especially with high shares of renewable energy sources. Motivated by the potential performance degradation due to the overfitting of the prevailing stacked bidirectional long short-term memory layer associated with its linear stacking. We propose a Bi-LSTM network has been widely investigated as a powerful forecasting model as it can improve performance by eliminating propagated errors, especially when the number of parameters increases by residual learnings. In this method, we are going to find the forecasting results of mean square error, mean absolute error, and mean absolute percentage error for training and validation. The method provides a good framework for time series forecasting applications, especially in grid power operations. The flow diagram of the project is first we need to start the program, and we are going to select the dataset as a GNOS climate dataset, and we use the dataset, then it will apply into pre-processing method. In pre-processing method, we are going to check the missing values in our dataset. If it is any missing values in our dataset, we need to replace the missing value by the default value of 0, and then it will apply into the feature selection module. In feature selection method, we are going to split the dataset into training dataset, testing dataset, and validation dataset. Then it will apply into forecasting method. In forecasting, we are using Bi-LSTM algorithm. In that, we are going to find the result based on mean square error, mean absolute percentage error. Now I am going to explain the output of the program, and this is the dataset that we are using in our process, and this is the description of our dataset. In that, we are going to find the count value, mean value, standard value, minimum value, 25%, 50%, 75%, and maximum value of our dataset. And then we are applying to pre-processing method. In pre-processing, we are going to check the null values in our dataset. If it is any missing values in our dataset, it will replace the value in 0. But in that, we don't have any missing values in our dataset. Then we are going to find the shape of our dataset. Our shape of our dataset is 20,551 rows, and this is the mean value of our dataset, and this is the variance of our dataset, and this is the maximum value of our dataset. This is the Bi-LSTM summary model results, and in that we are going to find the mean square error, mean absolute error, mean absolute percentage error, and validation mean square validation mean absolute error, and also validation mean absolute percentage error. These are all the results of our Bi-LSTM model. It will show the results based on every approaches. And this is the test prediction graph results. And this is training mean square error, and training mean absolute error, and also the validation mean square error and validation mean absolute error graph. And the final result of test score is mean square error is 0.00075, and mean absolute error is 0.019, and mean absolute percentage error is 3.95.